Okay, so the very first question that we are going to be looking at is this question here. Let n be a natural number. A natural number is a counting number. And the question is, sorry, just one moment, please. One moment, please. I'm trying to connect my writing pen. All right, here I am. Let n be a natural number. If the tens digit of n squared is equal to 3, then what is the last digit of n squared? First, we have to understand the problem. One of the most important things in problem solving is to understand what the problem is saying. We say n is a natural number. That means n is a counting number, like 1, 2, 3, and so on. And then it also says that n, when you write it down, the tens digit, we don't know how many digits it's got, but the tens digit is equal to 3, and there is a units digit. Right, the tens digit of n squared, of n squared is 3, and the question is, what is the last digit? Okay, so there is very little information given in this. All you know is that this is the square of some number, and what is the last digit? All right, to do this, there are some references even in your book, the training manual book, which you can access, all of you. You can read the relevant sections, and you will get some very important information in chapter 1 especially, on how to solve this problem. All right, the very first thing is, you got a square of a natural number. What does it end in? Right? Now, when you got a square of a natural number, and the number ends in 1, for instance, and you're squaring it, then the last digit is then 1. Right? If the number ends in 2, and you are squaring it, the last digit will be 2 times 2. If the number ends in 3, right, and you have 3 squared, 9. But when it ends in 4, then 4 squared is 16, so the last digit will be 6. And like that now, 5 squared, 6 squared. Now when you come to 6 squared ends in 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, and these digits are repeated after you go past 5. So the only possible values for this question mark is 1, 4, or maybe 0, because if it ends in 0, then you could have a natural number ending in 0, like 10, right? So these are the only possibilities for the ending. So that eliminates numbers like 2, 3, 7, 8, for example. Okay, so now the question is, now we still haven't brought it down to to exactly one answer. Right, so how are we going to sort of figure out what this is going to be? Now observe something here. Either n is even or n is odd. And we want to see what happens to the square of an even number. So if n is even, n is equal to 2 times something, 2k or whatever, where k is an integer, and the square of n will be 4k squared. Now, this is a multiple of 4. So if n is even, the square of n is a multiple of 4. Right. Now, you know by the rules of divisibility, that the multiples of 4, a number is a multiple of 4 provided that the last 2 digits of that number is a multiple of 4. Okay? So you want these last 2 digits to be a multiple of 4. Okay, so what does that mean? 30 something must be a multiple of 4. It can be 32, 36. That's all. These are the only 2 possible multiples of 4. So which means 32 is eliminated. Right. So in other words, if n is even, it is one of, the question mark is one of these 2 numbers, but 2 is not here. The only number is here is 6. So the answer is 6. That is provided n is even. So the last digit of n squared is 6 if n is even. So let's just put that down. If n is even, the answer is 6. I'll just repeat that. The last 2 digits must be a multiple of 4. The only multiples of 4 which start with 3 are 32 and 36. So you can't have n squared ending in 32 because it can only end in this. So the only possibility is that it has to end in 6. Okay, so that takes care of the even part, but we still must take care of the odd part. But when n is odd, then it must be an even number plus 1. The odd numbers are always an even number plus 1. So it will be looking like this, 2k plus 1. And when you work out n squared, 2k plus 1 all squared, you square it, you get 4k squared. And then you multiply these 2 and multiply by 2 again, 4k plus 1 squared, which is 1. So yeah, when n is odd, what happens? You have that n is equal to 4 times something, there it is, 4k squared plus 4k, that's 4 times something, plus 1. So in other words, it is 1 more than a multiple of 4. Right? So when n is odd, it's 1 more than a multiple of 4, and we already saw the multiples of 4 here with the tens digit equal to 3 are these. So in this case, you will have 1 more than the multiple of 4 are 37, 33 at least, and 37. So in this case, n squared will end in 33 or 37. But you notice, in this case, the units digits is 3 or 7, and that's not here. So the odd numbers don't contribute anything to this problem, because a square of an odd number can never have 3 as a tens digit. You see, it will have to be end in 3 or end in 7, and that cannot be a perfect square. So therefore, the odd numbers contribute nothing to the problem. The only answer is given by the even number, so the answer is 6. So the answer to this problem is 6. All right, now the next problem. Okay, Alex, you were the first one who told me the answer is 4. Can you explain to me why you did that? Put your mic on so that all of us can listen.
So I started by finding how many 2's are in that product, 1 times 2 times 3 times 4 times, and I found that there are 2 to the power 8 is in that product, so 4 to the power 4 is in that product.
All right.
So x equal 4.
Very nice. Thank you for that, Alex. I just want to reiterate what Alex has said. Um, what Alex says is he saw how many 2s there were in the product. Okay, and what's important here is when you took the 2s out, the remaining number is an odd number. I want to just point that out. All right. So this is 2 to the power of, this contributes 1. There's 1 here. This contributes another 2. So it's 1 plus 2. This contributes another 1. And 8 contributed 3. And 10 contributes another 1. And the remaining factors are all odd numbers. If you take 2 out, then you have 3 here, and you got times 5. So you're taking out the highest power of 2. So you're going to have an odd number here. So the product of odd numbers is odd. And here you've got 2 to the power of 8, as Alex correctly pointed out. So this is 2 to the 8 times an odd number. So the highest power of 2, you have to write this as 4 now. So this is, as you said, this is the same as 4 to the power of 4 times an odd number. So therefore, the highest power of 4, which is a factor of this, is x must be equal to 4, because this contributes nothing towards the 4. Okay? All right, thanks very much for that. We go on to the next problem. The next problem is, let me get to the next problem. So again, I'm giving you a chance to tackle this problem. I'll give you 5 minutes. Let me first explain to you what the problem is. Determine the sum of all integers x that satisfy this equation. Now you've got x as an unknown here, but it's a very strange equation, which I'm sure you've never ever seen an equation like this. And you've got something to this power equals 1, right? And you want to know, this is an integer. So you've got x as an integer. Which integer, by the way, integers are negative and positive whole numbers. So you want to know which integer raised to this. Remember, x is in both places. Raised to this is actually equal to 1. Okay, so try this out.
If you look at the problem, so to get 1 at the end, there are basically 3 ways to do that. Base of negative power of num and to the power of 0. So to get 1 as the base, you use 2018 as your first solution. Then to get 0 as the power, you use negative 2020. And to get negative 1 as a base, you use positive 2020 and you check. So 2020 plus 2020 is indeed even. So you see that the 3 solutions to this problem is 2018, 2020, and negative 2020, and their sum is 2018. So 2020, negative 2020, and 2018.
All right, so Johan says that there are 3 possibilities for the value for x. And then when you add these up, the sum of all these integers. So you say, Johan, the answer is 2018.
Yes.
All right, so let's analyze this and see whether how many of you agree with 2018? Okay. Right, so there are about 13 people who okay, that's fine. Now What Johan says is that there are three possibilities. I think many of you might not have seen those three possibilities. Well, the one of them is certainly when the index is 0. Any number to the power of 0 is 1. So when the index is 0, x is equal to negative 2020. So that gives you index 0. And then you said, well, this base could be 1. If the base is 1, 1 to any power is 1. In that case, x will have to be 2018 for the base to be equal to 1. Right. But there was one other one here which perhaps a lot of people didn't see, and that is that negative 1 raised to a power can be equal to 1, provided the power is even. It's important. So negative 1 to an even power is 1. Now let's see whether you can have such a situation. For this to be negative 1, then x has to be 2020, right? And when x is 2020, the power is 4040, which is even. So that's fine. So x equals 2020 will give you a solution, because that gives you negative 1 to the power of 4040, and that is certainly 1. So Johan is quite right. There are three possibilities where the base is 1 or negative 1 and the index is 0, and when you add these, you get 2018. Okay, well done to all those people who were able to get 2018. I see there were 17 learners, which is quite encouraging. Of course, there would be those who did not get it, probably didn't notice that you can get negative 1 here. I think that would have been the problem. Okay, now henceforth I'm not going to give you too many opportunities to solve problems because it's quite time consuming. We've already gone through 38 minutes and we've just done 2 problems, so 2 or 3 problems. So I'm going to go on quite briskly. Hopefully you have already tackled these problems, in which case you wouldn't have any issues. But if you did not tackle the problem, it will be brand new to you and you're not going to learn much, unfortunately. Okay. So the next problem is this problem here. 10 integers, not necessarily distinct, have the property that if all but one of them are added, the possible results are, and you've got several results. And the question is, what is the smallest of the 10 integers? Okay, let's just first understand it. I'd rather try this. It's rather difficult to understand when you say all but one of them are added and what these numbers mean. So I think what I'm going to do is take a particular case where I have, say, 5 integers and I test this thing out on those 5 integers. Let me just take 5 random integers, say let 4, 1, 6, 8 and 9, for instance, be 5 integers. Okay, now all but one of them are added. So you add everything but one means except one. So I can add everything except 4, for instance, right? So when you do that, when you add all but 4, that's 7 plus, this is 8. 7 plus 8 is 15. Alberto, can you please switch your mic off? Alberto. I'm going to make an appeal again to you to please switch your mic off. If I find that somebody is constantly disobeying, I might have to take that person, knock that person off completely, and I don't want to do that. So the remaining numbers are 24 here. Now, if you take all but one here, you got 4, 6, 8, 9. That gives you 27. And if you remove the 6, you have 5, 13, 22. You'll notice that what's really happening is you're adding all these, which gives you 5 and 6, 11, 19, 28. When you add everything up, you get 28. So really what you're doing is you're taking 28 minus 4, 28 minus 1, because you're removing 1, you see. 28 minus 6. So the next one will be 28 minus 8, and 28 minus 9, which is 19. And the question is, which is the smallest of these integers, right? We know the smallest of my 5 integers was 1, right? But from here, to get the smallest of these integers, you have to subtract from 28, you have to subtract the largest of these integers. So I have to subtract 27 from 28 to get the smallest of the integers which we are looking for, right? So now, in other words, we need, now where did 28 come from? It's the sum of all these integers. So we take the sum of all these integers and subtract from you need to know the sum of the original 5 numbers and for our original 10 numbers, and then from that you subtract the largest of those 10 numbers, and that will give you the smallest number. So I hope you understand that. So what we have to do, the goal is to find the 10 integers. So let's just write down these 10 integers. It's starting with 82. It's all increasing here, 82, 83, and so on. So starting with 82. So if you write down all the integers, how many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my goodness, there are 9 differences. But they said that there were 10. Now, what happened here?
So they are not necessarily distinct. So 2 sets of the sum add up to the same number.
All right. So Johan said that it seems that one of these numbers must be repeated. So some number is repeated to make it to 10. That's the only way, only explanation for this. So we don't know what the repeated number is. So let's start with that. Let x be the repeated number. There is some number which is being repeated. We've established that because there are 9 answers here. All right. Now we are looking for the sum of all the numbers. So let's add up all these numbers. But remember, amongst them you got another one, x, which hasn't been. Oh, yeah, the repeated number. Right? One of these numbers is repeated. So we're going to add up the sum of all the numbers. Now, the original set of numbers. Let s. Let's give a name to this. Let s be the sum of the 10 numbers. Okay, now let's find out what these 10 numbers are. All right, so let's give a name to this. We'll call these numbers A1, A2, A3, and so on, up to A10. This is the original set of 10 numbers. And so the first this 85 is really the sum of all these numbers. So if S is the set of all the numbers, sum of the 10 numbers, the first of these numbers will be S minus 85. That's one of these numbers. S minus 87, all but one, you see. So the original set of numbers is S minus 85, S minus 82. We shall start with S minus 82. Let's just put that down here. S minus 82, S minus 83, all the way up to S minus 92. And you'll also have S minus X, because X is one of these numbers. So these are your 10 numbers, which is exactly the same as your original 10 numbers, right? Now, so if S was the sum of the original set of 10 numbers, then you have that the original 10 numbers would have been these. And what does this mean? It means that when I'm adding all these numbers, we just said that the sum of those 10 numbers is S. So in other words, the sum of these 10 numbers is also S, because it's exactly the same set of numbers. So when you add all these numbers, you're going to get S, and that gives you an equation. So very, very important. Right. Now when you add up all these numbers, you have 9 S's here. Because actually, yeah, you have 10 S's. I'm sorry, you have 10 S's. So you have 10 S's, and you have all these numbers. When you add 82, 83, all the way up to 92, if I remember, I had minus 783. Right?
So you only have 9 S's because in each one of the sums, one of the numbers is not present.
Johan, I'm giving that number, that extra number, I'm giving it a name X. Right?
Yes, sir, but X is only a sum of 9 of the 10 numbers, not of all 10. So if you add all 10 partial sums, there is only 9 of every number, not.
Okay, you can come back to me later on, but please don't disturb me while I'm right in the middle of it. At the end of it, Johan, you can come in. All right, please don't disturb me when and that applies to everybody else. Later on, we'll ask you any questions, then you can make your comments. All right, so you've got. If it goes wrong, then you can tell me what went wrong here. So I'm giving a name X to the repeated number. So when now we've got 10 different differences, and therefore the 10 numbers which we have are S minus each of these 10. There are 10 numbers here, and you have, when you add up all these, you get 10 S's minus 783 minus X. But the sum of all these numbers, that's what I'm doing, is equal to S. So the sum of these 10 numbers is that, and now you see you can make S the subject, and you have 10S minus S is 9S, and there is 783 plus X. Right? So I'm going to just delete these for the moment. What I want to say here is that this is 9 times S, and 793 is also 9 times something, because If you add the digits, you get 18. So this is a multiple of 9, this is a multiple of 9. So therefore x is a multiple of 9. I want to stop there where x is a multiple of 9. Johan, you can put your statement in the chat column and then we will discuss that at some other time. Okay, so x is a multiple of 9. So one of these numbers here, the number that is repeated is a multiple of 9. Now if you look through all these, you will see that none of them is a multiple of 9 except 90. That is the only multiple of 9. So the number that is repeated, right? This is a very beautiful problem because you can zone in on what the x is by just noticing that x is a multiple of 9. So the number which is repeated is 90. So your 10 numbers are 82, 83, all the way up to 90, 91, 92. Okay? And now you want to know what is the smallest of the 10 integers. So now we have to see what s is, and we saw that 9s is equal to 783 plus x. I think that's what we had earlier on. And now x is 90. We found out what x was. So now s can be calculated, and you see that s is, if you divide this answer here by, you get s is 97. So the sum of the original numbers is 97. And the smallest number that you are looking for, as we said earlier on, will be this minus the largest of these. So you can see 90 was not the largest, so that didn't affect it. So the sum is 97. So your actual answer is 97 minus 92. That will be the largest value of, because the numbers will be now 97 minus 82. So that's the first number, 15. 97 minus 83, that's 14. Going all the way up to 5, 97 minus 82. And the smallest of the 10 integers is 5. All right, Johan, you can just make your statement down in your chat column, and then we will discuss that after the talk. Okay, did anybody were they able to figure out that that the smallest of the 10 integers is 5? I just want to see, in your chat column, can you please put a new chat? Okay, there's one person at least. Who was the person? Can you just show me your raise of hands? Okay. I'm glad there were a number of people who were able to come to s is equal to 5. Okay. Remember that you got 187 here, so the answer is already in the book. So getting the answer is fine, but what is more important for me is that whether you got it without having to look at the solution at the back. Right? That is the testing, right test. Okay, it's not whether you've looked at the answer and you know what the answer is, and you're telling me that you got the right answer. If you got it without having to see it at the back of the thing? All right, so let's go on to the next problem. The next problem is find 3 different positive integers, the sum of any 2 of which is a square. Find 3 different positive integers, the sum of any 2 of which is a square. Now, this is quite an intriguing problem. It can take quite a long time to discuss this, but so what we want to do now is the problem. Let's understand the problem. The problem says that I need to find A, B, and C three numbers which have the property that if you add a plus b, you'll get a square number. B plus c, a square number. And c plus a, that's if you take all possible ways of adding these two numbers. These are the three ones. So this is a square number. So you want to find what a, b, and c are, which makes this thing possible. So if you look at this now, you've got 6 unknowns. So it's quite a challenging problem. Okay. Now, we can actually, the way to do this is try to solve for a, b, and c in terms of x squared, y squared, and z squared. There's a very quick way of doing it. You want to find out what is a in terms of x squared, y squared, and z squared. There's a quick way. You can, one of the ways of doing this is, for instance, eliminate b. You can eliminate b from the first two equations, and you'll get a minus c, and then you can get x squared minus y squared here, and you get a plus c here, and then you've got two equations, two unknowns, and you can solve for a, and you can solve for c, and then substitute for c, and you can get b. Right? So that's one of the ways of doing it. Eliminate one of the unknowns from the two equations, and then you have two equations and two unknowns. Do that. But I've got a much better way of doing it. If you add these three up, you get 2a plus 2b plus 2c. Right? Now, so if you add them, you get x squared plus y squared plus z squared. That is 2a plus 2b plus 2c. So that's 2 times a plus b plus c. So a plus b plus c is x squared plus y squared plus z squared divided by 2. Right? So if you want a, you simply subtract b plus c from it. You see? It's a very nice trick. A squared plus b, x squared plus y squared plus z squared over 2. That is a plus b plus c. If I want a, I take away b plus c from this, and b plus c is y squared. So a is that minus y squared. And like that, b is x squared plus y squared plus z squared over 2. I have to remove a plus c from this, so I have to remove z squared, and then likewise and at this stage here, most people will come stumped. They wouldn't know what to do now, how to find A, B, and C, because there are too many unknowns. And you think, now, how am I going to find X, Y, and Z? The answer to the question is that there are many, many solutions. There are infinitely many solutions. In fact, if you put any particular value for X and Y, if you choose X and Y, right? I'm sorry, if you choose A and B, for instance, then you can calculate C. For instance, suppose I chose, I know that A plus B is a square, right? I was able to prove this morning that it doesn't, you can find infinitely many solutions, but if A and B is a square and both of them, one of them is even and one of them is odd, then you can solve this problem. Like for instance now, suppose the square is say 25. Right? Now you can choose a value like for instance A is equal to say 18 and B equals 7. Now, can we find C? That's the problem. Such that 18 plus C and 7 plus C are both squares. So that becomes a question. Can we find C such that 18 plus C and 7 plus C are both perfect squares? Now you can do it if when you substitute A and B here, right? And you try to solve this, it will be a nice exercise. I'd like you to try this thing out, right? And I'm telling you that I figured out a way of doing this thing here. 25, 24, 12, 6, 36. So here it is. I found my C. C is 18. Can you see 18 plus 7 is 25? 18 plus 18 is 36. And 18 plus C is 18 plus 7 is 25. Now, I challenge you to find out how did I get 18. And I just took two numbers here and I was able to find it so quickly. I actually developed a formula for this. So what you can do is you can try this. Put A equals 18, put B equal to 7, and try to find C, which will make this thing work. It turns out that there are many solutions. Each time you get a pair, there's a good chance. Sometimes you don't get but if one is even and one is odd, then, if one is even and one is odd, then you can always find the C, okay? But what happens is sometimes the C is negative. So you'll have to discard that and you have to try something else. Thanks. And you have to try something else. Okay, so, but for this particular problem, I would like you to see why C is equal to 18. So that's your challenge. So your question is, if 18 and 7 are two of these numbers, what is C? We know the answer, I just told you, but see whether you can actually come to that answer. And I don't want to go into too much of detail with that problem, but the question is just find 3 positive integers and you can do it. The idea is, what I'm saying is you can pick any 2 for A and B. As long as the sum is a square, then you can always find the third one, but provided that those 2, one is even and one is odd. So that is the thing. So please try this, and you can email me and tell me, look, this is how I did it, and I will mark it for you. Okay, let's see who is brave enough to try to prove to me why C equals 18 works. And there may be some other answers as well. Okay, so the next problem now is this problem here. The perimeter of a rectangle is 24 centimeters. So when you add up the 4 sides of the rectangle, you're going to get 24. What's the formula for the perimeter of a rectangle? That's one of the first things you learn. Right? It's 2 into length plus breadth, right? Okay, so you've got the perimeter is 24. Find the maximum area of such a rectangle. Find the maximum area of such a rectangle. All right, this problem is not really that difficult, but I can go through this somewhat quickly. So let's first understand the question. We are saying that we've got a rectangle and the perimeter of the rectangle is 24. Now, what does this mean? Well, we don't know what the sides, there could be many ways in which the sum of the 4 sides is 24, but it means that the sum of these 2 sides is 12, right? Because It's exactly the same as this. So the sum of the length and the breadth is 12. So you can have many ways in which you can have two numbers adding up to 12. You can have, for instance, 3 and 9. Right? And that will give you a perimeter of 24, but that gives you the area 27. Or you could have the sides could be, instead of taking 3 and 9 to be the numbers which add up to 12, you could have taken 4 and 8, for instance. And in that case, you will have 32. Or you could have had 5 and 7, which add up to 12, and the area then will be 35. Or you could have 6 and 6, and the area is 36. So you can see it's getting bigger and bigger and bigger. So which is the largest possible area that you can get, right? So certainly the maximum area is not 27. We came up to 36, right? There may be some other one which is larger than 36. So let's investigate this thing and see how one goes around solving this problem. So what we do now is, instead of calling the sides, giving any specific names to them, let's call them x. Let's call one of the sides x, right? And use mathematics to solve this problem. Okay, so if one of the sides is x, then the other side will have to be 12 minus x, as we saw. And in that case, the area is equal to length times breadth. So that is the area. Now we want to find what is the largest possible area value of this. The largest possible value of this. Okay. Now here, those of you will recognize that this is the graph of this is a parabola. This is 12x minus x squared. It's a parabola. The roots are, x-intercepts are 0 and 12. That's where the parabola intersects this. And it's got a maximum value because you've got a minus sign in front of this. So it comes down like this. So you want to find the maximum value of this. See the different x's now between 0 and 12. Right? X is 0, 12. Different possibilities. This x here will give you that area. This x here will give you that area. Because this is y equals x into 12 minus 8. So you can see the x which will give you the largest possible area will be that one. And this will be right halfway in between 0 and 12. And that number is 6. Because the axis of symmetry is here, halfway in between these two roots. So the largest possible value for x into 12 minus x is obtained when x is equal to 6. And we already saw that then the rectangle becomes a square, you see. And we saw that the area is 36. We did come to 36, but we didn't go beyond that, because if we went beyond that, we would have had 7 and 5. Right? So I cheated. I didn't go beyond that because 7 times 5 will give me 35, and you would have got immediately guessed that 36 is the answer. So if you guess the answer, because if it's a multiple choice, then you can guess the answer, and you would have been right. But you would not have known precisely why that is the largest. How do you know? There could be some other numbers which are very close to x, 6, which will give you something larger. You don't know that. But when you look at quadratic theory, that tells you that the maximum value is obtained precisely at 6. After that, it goes down. So the graph of the parabola turns. Those of you who are in grade 10, I don't know whether you have did the graph of the parabola, but those who are in grade 11 and grade 12 would be able to understand that argument. Okay. Now that's quite a learning experience. And this is a good example of where you have a non-routine problem and you use school mathematics to solve that problem, and you're using quadratic theory, graphs, and so on, you've got a good application of that problem. All right, so we now look at the next problem. Okay, so this is in red, so I want you to try this thing out. And Sama, you gave me Sama T. You said 5 and 19. Can you please explain how you got 5 and 19, please?
So if the newspaper has 24 pages, then the first sheet of paper on one half of the sheet, it's got page 1 and 2. And then the other side of the paper, counting from the back, it's got 23 and 24. And then if you count back from there, then you know that the second page has 3 and 4 on the one half of the page, and 21 and 22 on the other side. And then the next page has got 5 and 6 on one half of the paper, and 19 and 20 on the other side.
Okay, that's very good. So the first page, when you flip it over, you got 1 and 2. The next flip from the top when you read, you'll get 3 and 4, right? So the back of that will be the next two here, 23, 24, and here you will have 21, 22. and so on, and then eventually you will come to 6 and 20 will give you 5 and 19. 5, 6, 19, 20. That's how it goes. Okay, so the answer is 5 and 19. So this is not a very difficult problem. You have to just imagine you folding a newspaper. Thanks very much, Sama. That was a nice answer. Okay, so let's get on to the next one. Okay, this also, you can try this problem out. M and N are two different integers selected from numbers 1 to 50. What is the greatest possible value of this fraction? M plus N over M minus N. So you must select different values for M and N from these 50 numbers, and you have to figure out which is the largest possible one. Zandi Siva, can you just please explain to me how you got 99?
Okay, so basically with the integers from 1 to 50, I tried to get the highest possible integer, which is 50 minus 49. And then from there, I tried to make the denominator as small as possible, which is 1, which is obviously also 50 minus 49. And then I came to the answer of 99.
No, you could have had 2 minus 1 or 3 minus 2. Why did you take 50 minus 49?
So I took 50 minus 49 because it was the largest integer I could take from the top fraction, the numerator.
Okay, thanks very much. So you want this to be as small as possible, and the smallest possible value you can have is 1 here, and you want that to be as large as possible. There are lots of ways in which you can get 1, but the largest sum will be 50 and 49. So this will be 50 plus 49 over 50 minus 49.
Yes.
Okay, very good. Thanks very much, Sanisiva. All right, so we'll get on to the next problem, which is okay, next one says the sum of two consecutive numbers is S. What is the difference in terms of S between the square of the larger number and the square of the smaller number? So what do we have here? You've got the sum of two consecutive numbers. So let's give names to the consecutive numbers. Now you don't know what they are, so we can't say that they are 15 and 16, for instance. You must put mathematics into it, and you must just give symbols to them. So you'll say let n and n plus 1. Consecutive numbers differ by 1. Be the numbers, right? Okay. Now it says here that the sum of these two numbers is s. So n plus n plus 1. So the sum is s. So we can just write this equation down. S is equal to 2n plus 1. You simplify it. Then it says the square. What is the difference in terms of this between the square of the larger number? The larger number of this is n plus 1, and the square of that is n plus 1 all squared. You want the difference between that square and the square of the smaller number. The smaller number is n, and the square of that is n squared, and you want to work out the difference. What is this thing here equal to in terms of s? You have to write it in terms of s, maybe 3s, or s over 2, or whatever. Write it in terms of s. Now when you simplify this, the square of n plus 1 all squared, your n squared plus 2n plus 1, and then the n squared cancels out and you get to 2n plus 1. And if you look at 2n plus 1, it's precisely equal to s. So the answer is s, because when you simplify this, you get 2n plus 1, which is exactly equal to s. So the answer to this problem is s. So the starting point is you give names to the symbols. They are consecutive numbers, so you can call them n, and don't call them x and y. You don't use too many symbols. Try to, minimize the number of symbols you use. They are consecutive, so you can immediately say n and n plus 1, right? And then from there onwards, you translate what is given into an equation and go ahead and solve it. Okay. Okay, you want to try this out? It's a longish problem, but I'm going to give you very few minutes for this because it's easy. Quickly read through it and understand it, and try to solve it. And post your answer in the chat column. Okay, Joseph, you came up with the answer. Can you just tell us how you did this? Let me just explain the problem just in case people did not understand the problem. The problem is you've got a number of like 65 marbles, and you've got 20 each of one color, and then the other 5 of other color, yellow and something, and you're picking out marbles from there, and you want to find out how many must you pick out so that you have 10 of the same color, right? So Joseph, can you tell us how you got your answer?
So sir, the worst possible case you can do when picking marbles is 9 of each color, and then
it's okay. So the worst possible case, so you can pick 9 of the red and waiting for the 10th one to come, it doesn't come, right? Okay, yeah. Then you can carry on.
And then 9 of green and 9 blue, and then all 5 of the yellow or white ones.
Yeah, these ones they will never give you 10, so you can pick up the whole 5, and this will be. And now at this point,
and then now you've picked all of the ones, so the next one you pick has to be.
So the next one will have to be one of these colors here, which will give you 10. So you have to pick one more here. So the number of marbles you have to pick is 27, 32, 33. Okay. Thanks very much for that, Joseph. Okay, now let's look at the next problem. The next problem says a train. Read through that problem, please. Try to understand it. So what we've got here is a train is going through a tunnel. So let's draw some pictures here to understand what's going on. So this thing here is your tunnel, and this thing is your train. And your tunnel is the same length as the train. They're both 1 kilometer long. So this is not very accurate here. This length here is the same as 1 kilometer, and the length of the train is also 1 kilometer. Okay, so this is the situation. The train is coming towards the tunnel, and it just enters the tunnel. The time at this is 1300, 1 o'clock in the afternoon. Right. Now, the train enters the tunnel, and we want to see it's traveling at 20 kilometers per hour. Now, what is the meaning of that? It means that in 1 hour, it travels 20 kilometers. That's 60 minutes. .60 20 kilometers. So 3 minutes, it travels 1 kilometer. Now, I'm interested in 1 kilometer because that's the length of the train. So now here's the situation where the train is completely inside this tunnel. To do that, it's traveled exactly 1 kilometer. So you need to only look at the nose, the front of the train, and the thing goes in here and it travels 1 kilometer. And when it reaches this part here where the nose is just coming out there, then the time would have been 3 minutes past 1. Because it takes 3 minutes to travel 1 kilometer, right? And then now this nose comes completely out, and the train is completely out. Because I've got 1 kilometer here, it just leaves this thing, and the train, the nose has now traveled for another 1 kilometer, and that would have taken another 3 minutes. So this situation is at 1306. So that's the answer. At what time does the train leave the tunnel? The answer is 1306. Okay. By show of hands, can you tell me how many of you got 1306? Some people will say 1303. But a few people raise their hands. It's nice. Okay, very good. The number of you have those of you who have tried these problems, you knew that you were able to get it. Okay, so please try them. Otherwise, there's no fun. You cannot do mathematics without looking at the question. Some people, they want to look at the answer before they find the question, which is actually very silly. Okay, so the next problem is all right. A solution containing water and a liquid concentrate, a 60% concentrate. Read through this problem, please. All right, so what is it saying? It says that you got some container which has got water and a liquid. Let's just, it's always nice to draw pictures so you have an idea as to, with a visual of what's going on. So I'm going to draw this container. Like that, and it's got this liquid in it. Okay, it contains concentrate and water. So we'll just have a look at that liquid. All this is liquid underneath, and part of it is concentrate and part of it is water. So let's just, we know it's all mixed up, but just for the sake of our thing, let's just put why is this not open? I chose a color, but I chose the color white. So that is why it wasn't coming through. Okay, so you got concentrate now, you see? So you got all these things of concentrate. Now this is the liquid. So this is a liquid. And 60% of this liquid is concentrate. Let's just do it in fractions. 60% of this entire thing is concentrate. I don't know how much of liters of liquid I got here. So suppose we got all together, you got X liters. %60 is 3/5, right? So it means that 3/5 of X, which is 3X over 5, is concentrate. And the remaining part is water. That's 2/5. 2x over 5 is water. Okay, that's not looking very clear, unfortunately. So let me just do that properly. Let's assume that this is water here. Okay, sorry, all this takes us so much of time manipulating around this board here. So you got 2x over 5. And these two together give you x liters altogether. But this is water. The blank part is water and this is concentrate. So what happens now? Now 20 liters of water is added to the solution. So the new amount of water is 2x over 5 plus 20 liters. X is in liters. Okay, so that's the new amount of water. And the concentrate is still 3x over 5. Nothing has been added to the concentrate. So after 20 liters of water added, this is what you got. And the question is, how many liters of the original? Oh, okay. The concentrate is now reduced to 40%. Now, how do you calculate the percentage of concentrate in this combined thing after 20 liters have been added? Okay, so you look at how much of concentrate are there. It's 3x over 5. Right? If you want to know what the percentage of concentrate is, you take the amount of concentrate and put it over the total amount of liquid. If you want to know the percentage of concentrate. Total amount of liquid, originally there were X liters, and you added 20 to that. So this is the total, the fraction of the concentrate in the new scenario, and that concentrate is 40%. Which is, as a fraction, is 2 over 5. All right? And then, now you can just work out what x is. I think your x is equal to 40. Okay, I'm not going to go through all the processes. So X is 40. Now that is the number of liters. X is the number of liters you had originally in the container. Now they ask you how many liters of the original liters was concentrate. So X is not the answer. The answer is 3x over 5, because you want to know how much of concentrate there is. So from this equation, you can solve for X, and you see X is equal to 40. And to work out how much of concentrate, how many liters of concentrate there, it has to be 3x over 5, which is 3 times 40 over 5. That gives you 24. So the number of liters in the original solution, which is concentrate, is 24 liters. Now I'm giving you these problems because very often you have problems like this, and it's not easy to solve them if you haven't seen it before. So this is a prototype problems like this. This is how you work it out. You know, you start off with an unknown, you give a name to the unknown. In this case, I don't know how much of water there was, how much of liquid there was, and we are talking about percentages of that liquid, so we give a name to that, and then from there we calculate everything in terms of X, and then look for an equation. And here the concentrate is reduced to 40%. That is the thing that gives you the equation. Because now you say, if I work out what percentage, what fraction there is, I can actually calculate that fraction, right, here, in terms of X, and that is equal to 40% because it says that is equal to 2/4. Now you got an equation involving X. Once you got an equation, then you can go ahead, solve it, right, using the methods that you have been accustomed to in school, and continue to solve the problem. So this is an example of application of linear equations. All we have there is a linear equation. Nothing more than that. The sum of squares of 3, the next problem. Can I have a look at this problem in the meantime? The sum of squares of 3 consecutive integers is 770. Well, there's no question here. I don't know what the question was. The question was probably find the numbers or something. Okay, whatever it is, let us find these numbers. The squares of 3 consecutive numbers. So you got, they are consecutive positive integers. So you can let the smallest integer be n. The next one is n plus 1, and the next one is n plus 2. And these are 3 consecutive integers. Usually it's better to put n in the middle. I like putting n in the middle, and then you have n minus 1, n plus 1. Usually a lot of calculations simplify when you do it like this. Right? Now you're squaring all these, and you're adding them, and you get 770. All right, now you square them and you add them. So the equation is immediate. There's one unknown, namely n, and you can use this as a quadratic formula. You can use n, and you can calculate what this is. But I wouldn't have done it that way. I would say that these numbers are very close to each other. Right? So we can assume that the squares also are somewhat close to each other. So what we do is, these are approximately the same. So I'll divide 770 by 3. I get 256 and something. And I see 256 as a square. So it seems to me that this 16 is going to be one of the numbers. This is 16 squared. And if you try 16 squared plus 15 squared maybe, plus 17 squared. I think you'll probably come to that. But you just try them with 16 inside it, and that will lead to the answer. But the idea is, I make an estimation of what n is and try it out and see whether it works. Right? Instead of solving this rather complicated quadratic equation, because you're going to get 770, which is a very big number, it's not going to be easy to work with it without a calculator. That's the problem. Right? So we'll say, well, these numbers are very close to each other, so therefore the squares would be somewhat close to each other. So we can say that these are approximately equal to the middle square. See? So they'll all be 3n squared equals that. So the middle one is probably 16. Let's try this thing out. 15 squared is 225. 16 is 256. And 17 squared is 289. 5 and 6, 11 and 9, 20. 2 and 8, 10. Yeah, okay. Bingo. That's the correct answer. See, by an estimation, we quickly found out that this is going to be, the middle number is going to be 16. So that's also another way. It's a problem solving technique where you can go quickly by making an estimation, trying it out and see whether it works, because you've got multiple choice, and you can exploit that method and try it out and get on to the next problem, so you have extra time. Otherwise you will take ages to solve the quadratic equation and waste time with it. Especially in an Olympiad exam, you need as much time as possible. So you can exploit the fact that you've got multiple choice. All right, so the next one now we are looking at is let me see, I've got 9 minutes left. Okay, let's try this one. This is a nice problem. Read this question. All right, you have to try to understand this question here. The question says that you write down all the numbers from 1 to 500. Well, I'm not going to write all those numbers, obviously. I go all the way, and it's going to land up at 498, 499, 500. Right? And then I delete numbers from the sequence, such that the sum of any two numbers of the new sequence is never a multiple of 7. What I'm going to do is I'm going to delete these numbers so that the sum of the numbers in the new sequence is not a multiple of 7. So I can retain 1, I can retain 2, and retain 3. But I can't put in 4. The 4 plus 3 is 7, so this thing has to be eliminated. I can't put 5 because 5 plus 2 is 7. And I can't put 6 because 6 plus 1 is 7. But mind you, I can put 7 because 7 plus none of these numbers is a multiple of 7. So I can't put 7. But now if I go on and look at, let's do it from here. 8. I can put in 8, because 8 plus none of these give me a multiple of 7. 9, 10. But I can't put 11, because 11 plus 10. So what happens is that I have to eliminate 11, eliminate 12, eliminate 13. And I have to eliminate 14 as well because I have a 7 here, you see. So I have to eliminate this. So that gives you an idea that if you go up to 21, you will have 15, 16, 17. And the last digit here is 21. So each time you only have 3. After 21, you'll have 22, 23, 24. Now the problem is, what is the maximum length of this new sequence? I want to know how many numbers are there, how many survivors are there. And the way I'm doing it, I'm finding the maximum one because I'm taking each one, every one of those, and I'm eliminating them. So you see that in each group of 7, I got 3 here, I got another group of 7 here, 3 there, and so on. And the last number in this is a multiple of 7. So we look for the last multiple of 7, less than 500, and you will see that 7 goes into 500 7 times 7, 1, remainder 3. So you have to, if you subtract 3 from 500, that becomes 497, right? And that is a multiple of 7. So you have some numbers here, 497, I'm not sure exactly what it is, but it's something like 491, 492, 493 or something. But there will only be 3 numbers. So in each of these groups of 7 contribute 3 numbers to this largest sequence, because these will be the largest possible survivors you will have. What is the maximum length of the new sequence? So how many are there here? So you will see that you have to count now. You got, there's 3 here, there's 3 here, there's 3 here, and 3 here. So all the way from 7 times 1 to 7 times 71. 7 times 71. So there are 71 rows here. 71 rows. Right? You can see it's starting from 7, 14, 21, going all the way to 497. And each row has got 3 survivors. So it's 71 times 3. But there is one row which doesn't have 3 survivors. And that's the first one. It's got 1 more. 7 is included there. So the answer is 213 plus 1, which is 214. So the number of entries in this sequence, in this new sequence, the larger sequence, is 214. Okay. All right, so there were some other problems here. I just want to see what they were. Unfortunately, we don't have time to look at them. I would appeal to you, you got the solutions in the book, as I told you. Look at the questions, try them out on your own, and then let's have a look at what these problems were. If today is Thursday, what day of the week would it be in 150 days? Oh, this is the last problem. Huh, not bad, I actually finished all of it. Oh, no, I didn't. This one here is another interesting problem. Okay, you can try that one. Okay, so we had only 2 problems which we didn't tackle. This one here, which is problem 218, and you can try to do that one. Right, it's kind of a long statement. Interesting problem. It'll be very similar to the previous one, so you can try it and see you can solve it. And the last problem is relatively easy. In fact, you can do it almost mentally. And I've got that as a red thing. Let's do that. You are supposed to try this. So I'll give you 2 minutes because we are at 10:59. try this last problem. Aisha, I see you solved the problem. Can you tell us what you did?
Since the 7 days in a week, I divided 150 by 7, and then
Yes.
I got 147. I got 21 with a remainder of 3. So 3 days after Thursday would be Sunday.
All right. So what Aisha did was, I think most people got it, did the same thing. So she divided this by 7. So let's see why she divided it by 7. The reason for that is, see, today is Thursday. In 7 days' time, it'll be Thursday again. And 14 days' time, it'll be Thursday. So you have to see the multiples of 7. And you're going up to 150. So you want to get to 150 as close as possible. You're looking for a multiple of 7, which is very near 150. The way to do that is to divide 150 by 7, like how we did the last time. There's a remainder of 3. That means that if I take away 3 from this, that will be a multiple of 7. It's very important. The remainder means when you take away the remainder from that number, it will be a multiple, you see? So you can see 7 goes into this exactly. So this is a Thursday. And then after that, she says 148 is a Friday, 149 is a Saturday, and therefore 150 is a Sunday. A number of people got the answer Sunday. Okay, well done, guys. Whoever came to that, thank you very much. And we've got two problems for homework. One is you do this one here, number 6, the one which I didn't do about the long problem, the one just before this one. And the other challenge I gave you to say why I had 18. You can write to me on the challenge problem, and I'm taking a big chance to get all these solutions coming from everywhere. But I'll be very happy if you can tell me how you came to 18. Thank you very much, and you have a nice weekend.